No, I'm not.
You're
I'm going to be up
live.
here Saturday.
All right, everybody. It is 7:29 p.m. Thank you very much for joining us all at the quote-unquote Macomb meeting of the Warren Astronomical Society, our third Thursday meeting of the month. We have a fabulous guest speaker with us tonight, the kind of guest speaker that our virtual meetings are making possible. And first off, I'd like to kick things off with the officer reports. So as many of you know, we were hoping to have the picnic in honor of Stargate's 50th anniversary this upcoming Saturday. That would be the 50th anniversary of the Stargate original dome and original telescope seeing first light. Because of the ongoing issues with both access to the observatory and plague, we reluctantly decided after polling the membership to cancel the picnic, and in its place we are going to be having a virtual get-together to make it a little bit different than your typical virtual discussion group and or open house. We are encouraging everybody to bring recipes, bring a dish, swap recipes, have your favorite festive dish on hand. We already got an amazing looking Jupiter Jello mold, courtesy of our outreach chair, Bob Tremblay, that I am super looking forward to trying. So I'm going to be, in the spirit of festivities, sending that out to y'all tonight so that it'll spark your interest in doing something really cool to share for the picnic. So the picnic will be like this, a WebEx starting at 6 p.m. In the event that we have good skies, we hope to do some virtual observing. If it's not good skies, because hey, it's summertime in Michigan, we can look forward to possibly some image processing demos and definitely sharing pictures. I know a lot of you have fabulous, fabulous pictures to share, so we'll make it like a show and tell. That's something that you all have enjoyed very much in these virtual meetings, and this time it'll be unfettered, no need to cut back to the break for a business meeting or a presentation. Just share your stuff, geek out, have fun, and enjoy each other's company. Any questions from the membership about the virtual picnic coming up this Saturday? All right, very cool.
Looking forward to it.
Yeah, I am too. I'm looking forward to making that, trying my hand at Bob's Jello recipe. So, another thing that we've got coming up is, believe it or not, it is August. That means November is election time. We did change the bylaws last time so that people can run for office for 3 terms. It doesn't mean that everybody necessarily would like to. And we do have, so in the event that you are interested in taking a place at the board, strongly encourage you to think about it. Maybe come to our next board meeting if you haven't done so in a while. Let's catch up where we're at in business. Talk to the board members. I would hope that every board member who declines to run for re-election would, maybe tap somebody on the shoulder that they know could do a good job and say, hey. But unfortunately, in a virtual context, it's a bit harder to tap people on the shoulder. Some of these conversations are a little awkward to hold through WebEx. So just if you're interested in serving the WAS, let us know, because we can't just see you anymore. That concludes the presidential report. So I would like to turn things over to Dr. Dale Parton to give us the update on programming.
Sorry, I had to unmute myself. Thank you for the handoff. Well, our next meeting will not be on the first Monday in September. It will be on the second Monday, September 14th, because of Labor Day. Please, everybody, make note of that. Our speaker on the 14th will be Jim Shedlowski, speaking on discovering the dark universe. Then 3 days later, at our quote-unquote Macomb meeting, our speaker will be Dr. Ryan McDonald, who's a professor at Cornell University. and associated with the SETI Institute. His topic will be revealing the nature of exoplanet atmospheres. Looking farther into the future, especially early next year, I have some openings and need some speakers. So, as with a lot of other things, I can't come around at one of our meetings and gently tap you on the shoulder, offer you a potato chip or something.
Lots of wasps still. Some of them has nested inside. I got rid of one nest. They didn't like that at all, so I had to get out of there in a hurry. Other than that, everything else is fine. We don't have any problems with the equipment, no leaks. Both buildings are okay. I left the room in the job shed so we can use it again. Got rid of some also wasp nests on the outside of the building, a couple of them. So other than that, really everything is still there. Everything is in working condition. It's just it's still going to be obviously closed for a while. Now, the park closes, I think, officially at least closes at 8 o'clock in the evening. So once we get into the winter months, maybe we'll, depending on what's happening with COVID, even though they may be closing it early, we'll see. But it does get dark also earlier, so we may be able to sneak in there for an hour or two of observing. We'll see how things go later on. Other than that, everything is fine, and that's I sent the report already for the WASP, and we're done with that.
Excellent, thank you, Riyadh. I am indeed hoping that we can sneak in for some 5 o'clock to 8 o'clock observing later this year. And with that, I'd like to pass things to our treasurer, Mark.
Hey, good evening, everybody. Let me give you a quick update. As of the end of last month, we're up to 90 current members. We've taken in $1,965. We've spent $510 this year. We have $22,300 in the bank, $22 in checks, $655 in cash, for a grand total of $22,968. And that was as the end of last month. Thank you.
Excellent. And now for Glenn, our secretary. I can't hear you, Glenn. You keep hitting the mute button twice, I think, Glenn.
No, I was unmuting him. We apparently were hitting the button at the same time.
Okay. One of you hit the button and let's
go.
There we go. Thank you.
Sorry about that. The Cranbrook minutes are approved and ready for WASP publication. And the annual letter requesting banquet door prizes has been drafted and will be available for board review this week. Back to you, Diane.
Short and sweet. Thank you very much, Glenn. Bob,
Yes.
outreach, and could you fold, I know we've got the GLAC president on the line, but any WASP specific content for GLAC in as part of your report?
Oh my goodness. Well, okay, first of all, in the chat, I am hitting right now the Astronomy at the Beach page. I have been working madly on the Astronomy at the Beach events and stuff. This has a lot of the events already in, but not the observing events. WASP specific, I think there's still a couple slots open, and I would like, Makani is going to be on a teacher panel. If we have any educators specifically who teach astronomy, I'd be interested in one or two of those, and I believe we have a couple slots open on the Ask an Astronomer panel that David Levy is volunteered to be on the next night. So we need a couple astronomers. I wrote the GLAC board saying that I would like to see at least one female, and I can think of two, and I'm looking at one right now. Anyway, so WASP specific, that's pretty much it. If there's anyone, again, who if you've been doing any outreach, please let me know so I can include it in the report for September. That's pretty much it.
Excellent. Thank you, Bob. And now let's pass things to publications and library, because we do have some library news.
Well, the WASP is up. We are gladly accepting your contributions for next month. Dale has been on the road, but he's about to be back in the Fortress of Solitude to fit in whatever he can that you send him. On the library front, we were given a donation of about 1,000 books from the library of Jim Lancaster, and he had one of the. I mean, his astronomy collection was, I would say, about as good as the WASP collection was in its glory days, if not better. So I've retained 4 boxes of those that I've added to the WASP library in captivity in our storage unit. And when we get that clubhouse built out at Stargate, or one of our host institutions gives us a bookcase again, they are ready to go. And Marty Coons has taken charge of the rest of the books and put them into the very empty bookcases of the McMath-Halbert Observatory. So all of the books are still available to WASP members. If you are interested in checking the ones that Marty has out, you can get into touch with him through the McMath-Halbert site, and we publish contact information for them in the WASP. And also Dale Taylor has taken charge of the Moon annex of the collection of donated books. And so you can look forward to reviews of all the books coming in future WASPs. And that's it.
Excellent. And that concludes the officer report, so we can proceed with the special interest group. I don't see Captain Solar Marty on tonight. Does anybody have an update from the sun they'd like to give in Marty's stead? I know the sun is still up in the sky, but beyond that.
I think there was one small sunspot that disappeared recently.
All right, that's been good enough for the last couple of weeks. I see astrophotography on the line. Bill, have you got an update for us?
I do. I'm up here at Cadillac West for a week, and 2 nights ago, Doug Bock came over, and I have a comment about Comet Neowise. Doug brought out his large binoculars, and we were able to see it in the binoculars. So what I'm getting at is it's still an astrophotography target. So the way to find it is about 10:30 at night, a fist's length be southwest of Arcturus. So find it in your binoculars and set your camera up on a tripod and start with 30-second exposures at 1600 ISO, and you should be able to see it. It doesn't have a tail anymore, but it's still a round fuzzy comet ball. So that's my suggestion. You can still get a nice picture of it if you want.
Bill, I was fortunate enough to get a picture. Last time I got a picture of it, it barely still had a tail, and I think that was around 2 weeks ago. And so now I have to proceed it far enough that there is no tail. So,
You sounded pretty ropey there, Adrian. You sound like you're being filtered through a rotary phone.
I think what Adrian said is he was able to look at it a week ago or so, and it doesn't have a tail. And he's correct, but it's still a big round fuzzy comet ball, so it's worth a try getting out there with your camera on a tripod, and especially with large binoculars. We had to use Doug's pretty good sized binoculars to see it. So yeah, I think they're 15 by 70s. So it's still visible, and get out and take a look.
Sounds good. Hope to do so this weekend. History group.
Well, as you probably remember from the Cranbrook meeting, I was busy having a crash course on all things Frank Lloyd Wright. So not a whole lot of WAS history has been happening since. So maybe next month.
We did just hand over you a stack of books for Armchair Astronomer work.
Well, that's a different category now.
Yeah, we might have to revive that award at the end of the year.
Okay.
Gail is making a play for
You're going to have to make 90 of them or something. I think we all deserve it.
Hey, I've done more observing this year than I have in probably a decade.
So, Adrian, hopefully we can hear you this time, but as president of GLAC, if you could give the GLAC report.
Sure. How well can you all hear me? Am I still
It still sounds like you're talking through a fan. Did you try leaving? Adrian, did you try leaving the WebEx and rejoining? Because that's the only thing that works for me. It doesn't seem to recover.
You're probably hearing a bunch of noise. I'll stop my video. I may try that unless the quality of audio is starting to get better. Is it getting better?
No, so WebEx doesn't seem to recover when you have a bad connection. I think you literally have to completely leave the meeting and rejoin.
Yes, please do that because we want to hear from you extensively.
All right, I'll do that. I'll be right back in a couple minutes. Or maybe 1 minute.
All right. Well, Adrian's trying to rejoin. Do we have any other subgroups, dormant or otherwise, that might want to make a report? Not observing report, subgroup related report.
There's merchandise still. If you want any, let me know. The post office needs the shipping fees.
Indeed. Seeing as we mentioned awards just now in passing.
Everyone.
Hello. Sounds like you're.
Am I back? Am I audible?
Yes. You sound good. So take it away, Adrian.
All right. So this is going to be a pretty quick GLAC report. Bob Trimbley, Jeff Cupmanis, and Brian Odom have done a ton of work on getting our virtual astronomy at the beach ready to go. The website is up. It shows that we're doing a virtual event, and we've got 4 big speakers lined up, including ours truly, David Levy. I want to call you Dr. David Levy, doing presentations. So it's quickly grown from it's quickly grown into an event that I think we'll all be proud of. Again, we'll field, questions about why we're doing it virtual and not physical, but there's a nice bright box that simply states for our safety and the safety of our attendees. So I do believe we have spots left for some presentations. We will be testing content. We'll be testing all of the connections over the next month. And we encourage you all to contact myself, Bob Trimbley, or Jeff Cupmanis, or Brian Odom, Dr. Brian Odom, or the GLAC board, contact@glac.org, to, if you have an idea for a presentation. So just if you have an idea for a presentation, let us know. We have a schedule out, and it is at the GLAC website, which is glac.org. Take a look at that schedule. We could always use more folks to do live streaming of their telescope, or their the word I want to use, the live session, virtual open houses. We're or virtual
we want to do a virtual star party with anyone and everyone that can stream their stream images from a camera, or stream what their telescope is looking at from a camera. So let us know if you can, and we accept any and all requests. Again, we will be testing during the month so that when September 25th and 26th happens, we're not sitting there fighting technical issues. Well, I'm sure that we will be. They always happen, but we want to be as smooth as we can for our first time having to do this virtual. So at this point, if there's any questions, I'll answer them to the best of my ability. Questions about the event, and of course I'm holding my phone. I need to hook it up to this thing. Questions about the event or anything else that you may have about the GLAC event, I'll be happy to answer. If no questions, then Diana, I guess I'm done for now until it's time for my next report.
All right. Well, thank you very much, Adrian. I think we have a solid 10 minutes that we can dedicate to observing. And we have, in addition to NEOWISE, we had the whole double Jupiter shadow transit that happened last week. So, first off, did anybody get to see the double Jupiter shadow transit? No?
Unfortunately, that event caused clouds for me.
Yeah, we were scuppered ourselves, but I was hoping with our far-ranging crew that maybe somebody had some clear skies.
So I
Say,
catch it. I caught the very tail end of it. And by the time it cleared up at my house, Jupiter was in the trees, so I had to resort to a small refractor moving through the yard. See it with a small achromatic refractor. Not as great. I hoped it was already starting to get kind of low, and the seeing was really lousy all night. And it was a strange weather pattern with the clouds. They pushed up from the south and they just stalled right over me. So for literally an hour and a half, Saturn was sitting there in plain view, and Jupiter never cleared the clouds.
yeah, I saw Jupiter from the window in the stairwell as I went to bed at 1:30, but it was too late for me to do any observing by that point. So.
Bummer. Did anybody else get any good observing in besides Bill and Doug? I know Doug's been up there knocking things out at Boone.
So
yeah, I've been up here. We've had 3 clear nights in a row, and I see some clouds in the south, the northwest right now, out my trailer here, so we may not get clear tonight. But we had the 25-inch didn't perform the first night, so we resorted to just the 18-inch. And the last night we looked at about 15 different objects before the clouds rolled in around 1 o'clock, including 18-inch, fairly large view with a 20-millimeter eyepiece in the 18-inch. It filled probably 2/3 of the field of view as far as the coma and the nucleus is concerned. Also went after the fireworks galaxy and a bunch of the stuff in Sagittarius. I won't go through the list. But we also switched over to the refractor. Rich Brenz had his 6-inch refractor out, and Jupiter and Saturn were just fantastic in that refractor. So that's my observing report. If you want, I can throw up. We'll do. No, I'll just pass on photographs tonight.
All right, or you can throw them up during the break. A lot of people hang out and would super appreciate it.
Yep.
So Diane, if I could share my screen real quick, I just want to give people a heads up on the next, say, 2 to 3 days, conditions wise.
Sure, throw that up there, Mark.
Okay. My gosh, I have so many windows open. Did that work?
Start connect.
Okay. So
There we go.
Yeah, so we got a stretch of clear days ahead, and looking at our clear sky chart on the Warren Astro site, we've got forecasted good seeing, especially tomorrow night, almost the whole night. And then referencing the site I mentioned in my short talk a month ago, this is the current jet stream, and you can see it's pretty well broken, missing Michigan right now, which is very good. This is looking at tomorrow night, even better, and Saturday, even better. So we're going to start to get into this kind of slow air. Today's been pretty gusty, pretty windy. It might still be kind of choppy tonight, but I expect tomorrow night and Saturday to have potentially excellent seeing. Looking at Medio Blue again, looking at the different layers, lots of green, with forecasted seeing in the arc-second range. So if you've got a scope, the next couple days should be good to get out.
Hey, Diane?
Yes,
Hello, I have an observing report.
I think we've got a queue, Gary. I think we've got David and Ken at his
Oh,
end.
all right.
and
All right, then
we'll-
I stand down, completamente. Forget it. Okay.
Well, we'd like to hear from you. It's just David and Ken both had their hands up first.
Yeah, but then it's going to run too long, so to hell with it.
All right, David, what have you got for us?
Yes, thank you. On the 11th, I was able to observe, it was very cloudy and rainy, but then suddenly cleared up at about 4 a.m. And during about half an hour, I saw 11 Perseids. On the next night, it was pretty clear, and over 3 hours, I saw 46 Perseid, mostly Perseid meteors. Finally, the night before last, or 2 nights before last, I was out with one of my telescopes and I did a little over 3 hours of visual comet searching. No luck, but I still love doing it. And that's my report. Thank you.
Excellent. I didn't get to see any Perseids myself, so I'm glad some people did. 46 sounds like a pretty good number. Ken, you had your hand up.
I want to let me put this on the screen here. I just wanted to show you the picture of. Wait a minute. Share. That's what I want. This is a different angstrom unit. You got it? Can you see it?
Yep.
Okay. And you can see that the sun is relatively active. If you take a look at the, see if I can get back to this real quickly. And this is, hold on. There we go. This is what it looks like, of course, to all of us. Not very attractive. There we go. And you can see a little sunspot over in the corner over here. And there's one down here. And that other picture was pretty much similar to that. And it's quiet, obviously. And there is some magnetic activity. There you go. Oh, it does that often. Okay, you can see some magnetic activity all the way through the whole sun. So there's activity, but what's that?
Only if you're Superman.
This is Soho. Oh yeah, right. I get it. All right. Anyway, that's from me. I'm done.
Gary.
Oh, Gary, come on. We want to
Yes.
hear.
All right. Tomorrow morning will be the end of at least the present trail of glory that I am blazing across the skies. I intend to observe R. Fornacis. It is the last of the selection that I have made from the Observer's Handbook, known as the Book of All Knowledge to those who care about such things. I've been observing carbon stars from the annual list of Astronomically and Husiak, and have insisted on using small apertures because we're in this for the sport, because it ain't for the money. And our Fornacis will be the last. 54 stars in my list that were taken out of the Observer's Handbook. And what is, oh, there it is, the Book of All Knowledge. Right. I feel a frisson. So I will be sending my report into headquarters, and hope that the two gentlemen who go to the trouble to make this list every year appreciate somebody out here in the provinces with small telescopes pursuing their carbon stars. And I have learned a lot about carbon stars as a result of this exercise. We experienced it last night with a variety of stars, no, the night before, most notably ST Camelopardalis and R Coronae Borealis. And those are details for another time. And the moral of the story is it's not the telescope, it's the observer, it's the operator. I am a man who stops at nothing.
And on that note, I have an observant
Man after my heart.
report.
All right. So, yep.
Yesterday was Diane's birthday, and so I thought this cake was pretty spectacular.
Very
So
well done.
that was.
So I see
that
there's
was all I
9
wanted.
planets. Is our moon in there, or does someone like Pluto?
I kind of put him up to it, I have to say.
Is that all edible?
Yes.
It is all edible.
Yes. The
Although I have to.
are fondant.
They do taste a little bit like Play-Doh. So if you, like me, grew up eating Play-Doh, you'll really enjoy them.
Yeah, it was a rose pistachio flavored cake in spite of the indigo color, so it was excellent.
It's platonic love.
Yeah. Or Aristotelian
It
love
looks
in this case.
It looks very festive.
Oh, it was incredible. Jonathan really shocked me. I got him the Jupiter cloud top cake last year, and this year one-upped me. I'll have to do something even more mind-bashing next year. Maybe a black hole cake. We'll see how that goes.
Excellent.
All right.
Well,
I think
Diane,
we're ready for
I'm
Adrian.
ready. Yeah, I'm
give
ready
us
to
the
do in the news. So I'm going to see what happens when I share my screen. It says share content, share screen. And I am now the presenter. So I queued up, let's see, 3 stories. And let's see. This one is interesting.
It's not showing up yet.
Okay. Let me do. I wonder if I have to share content. Let me go back here.
Yep, share content. You've got the presenter's ball.
Right. Okay. So if I go share screen, let's see, screen broadcast, start broadcast.
Yeah.
Okay. So it's about to start broadcasting what's on my screen. And
All right.
I'm going to start with this. Does everyone see it? All right. Just found this one and I find it interesting. It shows that we're moving towards getting a lunar lander once again. This is the Blue Origin team's version of a lunar lander. We won't be reading through all of these. I've got 3 stories to share and then a What's Up segment, which a lot of us that are observing kind of have an idea of what's up. So this one is a concept. I'll leave the picture here. It's a concept for a lunar lander. There are a few teams, obviously, that are doing concepts, and this one got delivered as of today, made space news. The company's developed a mock-up to allow NASA astronauts and engineers to fly. You can see it and you can read it if you want. So we are pushing ahead despite COVID-19. NASA is pushing ahead with plans on going to the moon and updating the technology that we had in 69 and the 70s. Let's see if I can find. Okay, this is an interesting article. Exploding stars may have caused mass extinction on Earth. This was as of 2 days ago. This story came out in Science News. You can see it. And so what it basically discusses is the radiation and the
perhaps gamma rays that may have happened around the Devonian what does it say, Carboniferous period. I can recall some of the animals like Dimetrodon that were living around that time. They're basically saying that it's possible that the supernovas and the rays coming from that contributed to um, the extinction. So this is an interesting article at how we can be affected by things happening millions of miles away. There's one other good story to share before I go into a What's Up segment, and I am looking for it. Let's see, I think this is not it. That's not it either. It was about Betelgeuse dimming, and I'm not seeing it. Oh, this is it. It's dimming again. So those of us know that Betelgeuse, um, there was an explanation a couple days ago saying that we were directly in the path of the dust that Betelgeuse may have shot out to cause its dimming. However, as David Levy mentioned at the beginning, at the top of our meeting, it's dimming again. So we're not sure why it's dimming again, but that means it's worth looking at. In order to see Betelgeuse, you have to wake up sometime between 4 a.m. and 5 a.m. because that's when Orion returns to the night sky. The winter circle is slowly returning to the night sky, starting with the Pleiades and Auriga, Pleiades and Auriga that rise right around midnight. And that leads me to the What's Up segment. And rather than listen to a What's Up segment, I just make it up all on my own. So these are some pictures I've taken, and this is the picture I want to feature. Andromeda Galaxy, taken with a DSLR and a 400 millimeter lens. Andromeda is back. So those of us like myself that practice learning how to image now have a good target. The Andromeda Galaxy is now rising again, along with the double cluster. I know Doug Bach mentioned some of the things that he observed. The double cluster happened to be one of them. The summer triangle, which I don't have in my images because it's tucked so far away. The summer triangle is now high overhead. We've talked about Jupiter and Saturn. Milky Way chasers, and I'll see if I have a picture of it. Milky Way chasers. This is actually an interesting image that I edited for a friend in the lowbrow. She caught a Perseid near the Milky Way. Now, there are Perseids and then there are Aquarids. The Aquarids are closer to the Milky Way, so what you're seeing here may actually be an Aquarid and not a Perseid. So if you do go to a darker park like Lake Hudson, where I've done most of my observing and imaging, you may see meteors to the south. Those may or may not be Perseids, or what's left of the Perseids. They may be Aquarids. There's a planetary nebula that's near and dear to my heart, NGC 7293, that's now rising in Aquarius and the water-bearing constellations. I think it's actually in Pisces. The Helix Nebula, a challenge to image because you do need to be able to use filters to view it, to visually observe it, and you use full spectrum imaging in order to capture all of what's in it. So that is rising now. I think you're seeing some of the squirrels that I take, but they're not up in the night sky and in baseball. So I'm going to stop broadcasting my screen. And as has been mentioned, we are getting a lot of good We're getting a lot of good weather now, and it's basically a perfect time to go out and observe, or image if you take your rig out and you set it up each and every time. So go out there and observe. If you can get to a dark sky park, it's a great time. Um, the winter circle next month, as we're doing the virtual astronomy at the beach, you'll see more planets. I haven't mentioned Mars, which is rising earlier and earlier and is a very good target for planetary observations. Um, Neptune and Uranus rise along with Mars, so for planetary, there's plenty to view there. Unfortunately, I didn't do much research on Mercury and Venus and when they would be coming back. So that will have to be for another time. But with this, that ends your In the News and What's Up reports.
All right. Thank you very much, Adrian, for your debut performance within the News in the Sky. Since that's wrapped up a little bit early, we have time for questions. Do we have any questions that anybody needs answered?
Yes.
Yes.
This is a question for Scholar Levy.
Question.
Do you favor the rename?
Sorry, Gary, you're fading out. Could you say that again?
All right.
I have a observing question.
Sorry, Gary was mid-sentence. Back to it, Gary.
No, I was waxing clever. Let Comrade Chudlowski have it.
Jim, go ahead.
Question for David. You were describing you're observing the Perseids the other night, and for several days, I guess it was the 12th, 13th, something like that, I was talking with some of my friends back in Arizona, comparing notes about observing here in Michigan and observing in Arizona at the same time, the same instance. They were talking about what they had seen, and I was comparing what I'd seen. And the question came up, if we are looking at the same instant at 2,000 miles apart, are we likely to see the same phenomena when we're looking at meteors?
No, the answer, and that's a good question, Jim, but the answer is no, because meteors are local, they're close. So if I see a meteor that's very close to the horizon and I barely can see it, somebody like maybe 50, 60 miles away will be able to see it overhead. And actually, in the past, we used to triangulate that way with people just 5 miles apart. We were able to calculate the height of a disappearing meteor from when the observing stations were only 5 miles. So if you're across the country, you're going to get a very different meteor shower from the ones we get. But that's a good question, and I'm glad you asked it.
Yeah, thank you for the answer. That kind of confirmed what we were surmising, because you just described seeing 25 the other night. I think you said something like that.
It was 46, actually.
46 you saw, and I saw 3.
Well, we're not supposed to be clear in the summertime, but sometimes we break the law and the sky clears, and it did on the night of the 12th.
Great.
But it doesn't look like it's going to be clear right now. It's pretty clear. There's a great big cloud right over us now, but still, we did get a very good and enjoyable Perseid meteor shower. There's the Alpha Aurigates coming up in early September, and there is also the Orionids in October and the Geminids at the end of the year. Looking forward to all of those.
I have another. I'm sorry. Did somebody else have a question?
Go for it.
Yeah, I have a question.
Go ahead, Dale.
My wife and I went out looking at the Perseids. I saw about 20. We went to a relatively dark spot about 10 miles away. No great fireballs or anything, but saw a lot of faint ones. But my question, David was mentioning there about, you know, the season and cloudiness. Is it me, or does this summer seem to have a higher than average amount of actually clear nights? We had a terrible spring, but I've been out observing and imaging quite a few nights this summer in the past, I would say, 4 to 6 weeks.
I don't think
It's many more.
We're having a good summer for imaging, observing, and it started, actually, it did start in the spring, right around the time things were locking down. I noted that for 3 or 4 straight days after things were locked down here in Michigan, it was clear almost every night. And, you know, if you thank whatever deities you want to thank, but I did notice that I was begging to leave the house and go image more than I would have expected to. And we did have that lull, I think, in May, but it's picked, or May and June, and it's picked up again. So it is, yeah, August has been a very good month.
There's
Yeah,
less air traffic.
Yeah, there's some speculation that it's really, you know, just the, you know, trails and traffic of all the airplanes through the sky actually does tend to nucleate clouds, and so the lack of planes seems to be leading to fewer clouds.
Where's
I'm
Ken?
not sure.
Where's Ken Burton with his T-shirt?
Hey, Diane.
He said he had his T-shirt on that said chemtrails aren't real.
Not chemtrails, contrails.
I know, I get that. But contrail, chemtrail.
Well, one of them is a conspiracy theory, and one of them is a fact of physics. So
Somebody said my name. What? Do you have one more question?
I'm sorry, you're very. We can't really hear you. Gary, speak
Testing.
directly.
1, 2, 3. Testing.
Yes, you sound
testing.
good.
Yes, good.
All right. All right. In inverse order of appearance, it has also been my impression in southwestern Michigan that we have had an unusual number of, let us say, clear nights, although not necessarily very transparent. But there have been a good number of clear nights. And of course, for an astronomer like me, these tiny obstacles like clouds mean so very little. And about the Perseids. Now, I am one of the ancient ones. And I remember, and it can still be found in reputable texts, that the hourly rate, the ZHR of the Perseids, should be at least 50 per hour. I remember the shower of 1977. We seem to have grown rather used to what I would consider insipid Perseid showers. In fact, there have been times in the last 25 years in which I was crashingly disappointed. I wonder if something's happening to the Perseids or whether our standards are going up. Over.
So I have a quick theory on that, Diane, before we move on. And
I do want to. I do want to let people know this is your 10 minutes.
Yes.
To relieve yourself and go get beverage or something.
We will be going live with the presentation at 8:30. So let's continue with the. Let's hear your theory, Adrian.
So my theory is this: with the ever increasing skies being covered with light pollution, combined with if the Perseids are now faint or now getting less and less because there's less material that's there may be a combination of a reduction in the Perseids. And those that were able to see it, such as you, Gary, years ago, know what a huge meteor shower is like. I remember in the 80s not seeing very many meteors, but then again, I was trying to observe it in Ann Arbor. Out at Lake Hudson, where where the meteors interrupt my imaging or they fly through my eyepiece, it became something where another meteor.
But what I observed, the few Perseids that I observed were pretty bright. And I was impressed with the 3 or 4 that I saw. I just knew that they were Perseids from one, where they were coming from, and two, how bright they were. So I'm impressed with what we see now, but I'm aware that things are changing in terms of viewability of the Perseids themselves. The matter that's a part of the Perseids is probably quote unquote drying up. So we're seeing less of them. So that's my theory. And I'm willing to have it challenged.
So,
It's
so the question that I was going to ask earlier was, and this is a factual question, but I don't know if anyone knows the answer, and I don't know if anyone in the world knows the answer. What is the most recently redeposited stream of meteors?
We didn't hear the question, John.
Sorry, so basically, what comet that causes a meteor shower came by the most recently in a path that the Earth actually connects with? And I think David Levy had an answer.
Yeah, I have an answer for the last 2 questions, actually. But there was a comet, the one that I discovered in 2006, that is the parent comet of the Cepheid, December Cepheid meteor shower. And what's known about those is that the meteors are very slow. They just creep across like airplanes. They are so slow when you see one. And I saw one beautiful one last year. The other thing, the other part, and has to do with the 50 meteors an hour. That you must remember assumes that the radiant is overhead, and you're observing in a perfect sky. So if you're in Ann Arbor at the university campus, you're not going to get 50 an hour, and a lot of those might be very faint. Also, the Perseid meteors are very, very fast, so they are extremely hard to get photographs of because they just scratch the sky quickly. The hominids are a lot easier to get to photograph that way.
Excellent point.
I got about 4 photographed, but none were like, they were all on the edge of the frame. They're not really good, but yeah, and many of them were faint, but quite fast, yes. Interesting.
I can see if I can pull up the I've got a couple that I imaged that I wonder if they're actually Aquarids and not Perseids because of their location near the Milky Way. But they were pretty impressive. And I will see if I can find them.
You should at least be able to tell, from the direction of the stream,
Yeah, and see
whether
the
they're
direction.
plausible.
Yeah, the direction of the meteors that I shot tells me that they may have been Aquarids. Here is one, and I will share my screen now. Share content. Share. Okay, it's sharing, and here is one that I posted recently, and I'm going to zoom it in. That's pretty bright. Aquarius is way over here and out of the screen. So could it be a Perseid? Maybe. I from what I understand, the radiant is where the meteors tend to originate from, but they could be anywhere in the sky depending on when they actually fall to Earth. So, based on the direction of this, it could be a Perseid. It might not. I don't know.
So I think the top of it is, I think it's falling down towards the horizon, right?
Yes.
So I think if you follow that all the way back through the sky, I think it is coming from Perseus. Because that's going directly into the south or to the southeast.
Yeah.
Southwest, and Perseus is in the northeast. So I think that actually is a Perseid.
So that
If
is
you
so that
follow the track far enough back.
yeah. So yeah, if you imagine this extends over my head, this was shot in Ann Arbor. I don't know whether you see it now. This was shot in Ann Arbor. I liked it, so I put a watermark on it at Brower Preserve in Ann Arbor with using a Sony A6000. And I forget how many seconds. I think it was one of those 30-second immaculate shots. There is another that I shot last year in 2019, and I don't know if it's impressive as this bird, but oops, I'm gonna see if I can find it because I recently pulled it back down to print, and I'm not seeing it. So, oh well. But well, actually, there's this one right here. This is an earlier one. And I have a couple copies of photos. I probably won't keep looking. I won't keep looking. I'm just gonna stop. But I have another one that if you go to the if you look at that Milky Way photo, the meteor was actually going away from directly along the line of the horizon, away from the Milky Way in the south, south by southwest. So that one, even though it was bright, I'm not so sure it would have been a Perseid. But I'm willing to accept that the one that I just showed you is a Perseid. So that, and I didn't see it when it happened. I was just running it. I was getting another lens to do something else, and I look up in the camera and I see that streak sitting there. So that's about how lucky I think you have to get to photograph a meteor, let alone a Perseid. It just happens to have to cross in the line of sight of your camera. So I was very happy because that so far 2 for 2 as far as Milky Ways and meteors going through them. So that's I was pretty happy about that, but again, I have to admit it's complete luck. Or your favorite deity maybe helps you out with getting those things. I was pretty sure until that night. No Perseids for me. I saw a couple good ones, but didn't think I was going to have any on camera. So
My favorite deity is Uranus. This is your
that's a good
2-minute warning. Our guest speaker, Robert Naeye, is going to start. We'll have Dale Parton introduce him in 2 minutes. So if you need to get a glass of water, or yes, Ken, go ahead. Or are you just saying hi? I'm just doing the
I wanted to just show you something. Adrian was talking about this Beetlejuice thing, and I actually have a great photo here of what they were talking about with the dust that was coming at us. You want me to just put it up there for a second?
Go fast, fast.
we just have to hurry along.
I'm going.
I can see you getting antsy, John. You're like, Jonathan, hurry! We want to be on time.
Yeah.
Okay. Here we go. Come on.
Can't leave the YouTube public waiting.
All right. There it is. You can see the dust that comes out from the blast that comes from it. And supposedly the dust was coming toward the Earth. So you see that in the next one. And so it looks like Betelgeuse is, in fact, dim because this dust is coming toward us. And that's what the representative. So when you see it from Earth, you see that thing there, and it looks like it's a little dusty. Just thought I'd give that to you. All right.
That is fascinating. I'm looking forward to seeing more.
And now we got to figure out if it's doing it again or if it's going to go kablooey for real this time.
Who knows?
2020, I wouldn't count it out.
But I thought that you might get a kick out of that. All right.
Yeah.
All right.
That's go ahead. I'm going to go on mute before we lose any more time.
Okay. So it's 8:29. Time to get for everybody to get back to their seats, bring in their virtual drinks, and I will now hand things over to our program chair to introduce tonight's guest speaker.
Thank you, Diane. Our speaker tonight is Bob Naeye, who may well be familiar to many people here as he was the editor of Sky and Telescope for many years. Bob worked for a time at NASA, excuse me, at its Goddard Space Flight Center in Maryland. He's also been a friend of our own Bob Berta since back around the year 2000 when they were both involved in astronomy events in the San Francisco Bay Area. Bob left California to move to Michigan at about the same time that Bob Naeye was also leaving to go to Cambridge, Mass. To work as senior editor at Sky and Telescope magazine. I can remember, I mean, I've subscribed to that magazine for decades. I remember when he was in that position, which he held for a long time. He has other connections to our society. He's known John and Rosie Blum for many years. They hosted him at their condo on Maui a few years ago. He tried to hire Jonathan Cade away from us about a decade ago to be their IT guy at Sky and Telescope, but then they weren't allowed to hire anyone. Good for us. And Bob has even spoken once or twice at Astronomy at the Beach out at Kensington Metro Park. These days, Bob is a freelance science journalist based in Hershey, Pennsylvania. His topic tonight is finding life on other worlds. Bob, welcome.
To unmute, or somebody needs to unmute him. There we go.
Can people hear me now?
Yes.
Yes.
Okay, am I coming through loud and clear?
You are.
Yes.
You sound great.
Okay, and so to screen share, I hit that rectangular button with the arrow, correct?
Correct.
Okay, and then I'll select PowerPoint, and I'll put it on. Is everybody able to see the slide okay?
Looks great.
Okay, great. Wow. So I just want to first of all thank Dale and Bob for inviting me to speak tonight. As Dale mentioned, Bob and I knew each other going pretty far back to our time in the Bay Area, and it was really kind of just a coincidence, if my memory's correct. We both moved away, I think within a couple days of each other for entirely different reasons. But fortunately, we managed to stay in touch with each other. And Bob invited me a couple times to visit, and I got to stay at his house and reconnect with his family. So that was great. And I also want to thank Jonathan. We did a Zoom session a few days ago to help me get set up with the technology for this webinar tonight. This is the first time I've ever done a meeting like this. So, we'll see how it goes. I hope you find my presentation more interesting than the DNC that's going on right now. And I want to just thank all of you for tuning in tonight. So my talk is based on a cover story I wrote for the current issue, September 2020 issue of Astronomy magazine. And even if you don't get astronomy, there's an accompanying web article. I think Jonathan in his publicity included a link to that article. In some ways, I think that article it's a little bit different from what I'll be talking about tonight, so you might want to check that out. I also just want to thank my editors at Astronomy Magazine, Allison and Rich, and the staff for the excellent work they did on the article. So my topic for tonight is how we can find life on other worlds. And of course, that raises very deep questions. What is the prevalence and nature of extraterrestrial life? And, these two questions have stimulated discussions among scientists for centuries. And we know from, popular movies like E.T. that we see here, that it's not just a question for scientists, the general public is very interested too. But despite all this interest and speculation, we really don't know who or what is out there. As critics like to joke, astrobiology is a science whose subject matter has not been proven to exist. You could say the same thing about string theory too. So what I'd like to see, and I think what scientists and the public want to see, is for astrobiology to be converted from, just a theoretical science to an observational science, which means we need to go out and find, what's out there. So I think scientists do have good reason to be optimistic that life is common in our galaxy and the universe as a whole. First, scientists have found chemical evidence in ancient rocks from Greenland, like the one we see in this picture, that life probably existed on Earth 3.8 billion years ago. That's well under 1 billion years after the planet formed, and not long after the planet cooled down after the late heavy bombardment. So because life got started very early in Earth's history, it's easy to imagine that life will get started, pretty much everywhere if conditions are right, meaning the presence of liquid water, organic molecules, and a source of energy. And then another reason for optimism is our galaxy has, somewhere on the order of 200 billion stars. And we know from the search for planets around other stars that there's an average of at least one planet per star. So I think it's very safe to conclude that the galaxy has hundreds of billions of planets, maybe even 1 trillion. And when we factor in moons as well, after all, and I'll talk about this later, some of the moons in our solar system might have life, then the potential life-bearing planets or worlds in our galaxy is literally astronomical. And another reason for optimism is, I'm sure all of you have seen the Orion Nebula. That's where planets and, stars and planets form in these large interstellar clouds. And the good news is that these clouds are brimming with elements such as carbon, hydrogen, oxygen, nitrogen, phosphorus, etc. These are all essential to life on Earth, but the stuff of life on Earth is common and widespread. Our galaxy is richly endowed with the ingredients for life. But, as I'll argue, I think it's still dangerous to draw conclusions from just a single example of a phenomenon. Maybe the origin of life on Earth was a once in a universe miracle. I doubt it, but we don't know. Maybe it's a miracle that life on Earth has endured for billions of years as our planet has undergone profound transformations. And maybe it was kind of a fluke that life managed to evolve from single cell and then eventually to multicellular life to complex plants and animals. So I would argue that we can't really answer these deep questions about life in the universe just by studying life on Earth, because we just don't know if Earth is typical or atypical. So as I discuss in my astronomy article, scientists are taking 3 different roads or approaches to search for extraterrestrial life. So imagine the road curving to the left, that would be exploring the solar system. Number 2, going down the middle, would be probing the atmospheres of planets around other stars to search for biosignatures. And then the road to the right, number 3, is maybe the funnest of all, and that would be the search for technosignatures from advanced civilizations. I do want to make it clear, though, that, even though there's these 3 different roads that are being pursued right now, it's not like they're racing each other. It's not like there's a competition. I think it's a healthy thing to have as many different options for finding life. And I would just argue we don't know how common life is, so it's impossible to predict how soon we'll make when we'll make the first detection of life on another world or how it will be made. But what I can say is that our technology keeps getting better and better. So if life is relatively common we might make the first detection in 10 to 20 years, but, I wouldn't want to bet a lot of money on that. So, I want to just firstly brief touch upon the question of what is it that we're looking for? What is life? And that's actually not, and I've read books about this. It's a question that doesn't have a simple answer, because on Earth, we see an incredible variety of life. I mean, we have microbes that exist in acidic hot springs in Yellowstone National Park, or cold, dry valleys in Antarctica, pores and rocks more than a mile underground, and even in the crushing pressures of the deep ocean. And then if we move to complex life, plants and animals possess an incredible range of forms and fill many different environmental niches. And I just got to put a plug for our former family cat, Baby, who we see at the lower right. He was a really wonderful cat when I was growing up. So just to talk briefly about the characteristics of life on Earth, because of life's extreme diversity, biologists have a difficult time even defining the term life. But here are 4 general characteristics of life on Earth. Life is based on cells, meaning a membrane surrounding a nucleus of genetic material. In our case, that's DNA. Life is a process more than a thing, and the process involves taking in some kind of nutrients or energy from the environment and converting it into something else. That's what we call metabolism. And photosynthesis, for example, is an example. Number 3, life reproduces, meaning it makes copies of itself. And 4, life evolves, meaning it's subject to Darwinian evolution and natural selection that produces changes over time. But what about life on other planets? And here's where things get really tricky. We don't know a whole lot about the physical and chemical conditions that are necessary to support life, because we only have this singular example of terrestrial life. So when you consider other planets and worlds out there, there must be a much broader range of environments that exist out there. So I think it's very likely that there are life forms out there that are totally unlike anything we see on Earth. So there was a great book I read a couple months ago as I was researching my astronomy article. You can see it kind of at the upper center, called Imagine Life, by authors Michael Summers and James Trefil. I thought it was a really good book. And in this book, they define 3 kinds of life. The first I kind of show in the slide here, and that's life as we know it, meaning life similar to what we see on our home planet. So that would be life based on the element carbon as a building block for life, life that uses liquid water as a solvent, and then life that uses DNA and RNA as molecules to encode genetic information. But then the authors talk about a second possibility, life as we don't know it. And here's a scene from Star Trek in which Captain Kirk encounters a Horta, a creature that's built from silicon rather than carbon. So I think this is imaginative science fiction that should remind scientists to be open-minded in their thinking of alternative forms of life. Excuse me just a second. And then there's a third possibility, and that's life as we really don't know it. So scientists need to consider life forms that are far outside our terrestrial experiences. For example, on the left, we have an illustration of, hypothetical plasma life that might exist on a star or even in interstellar space rather than a planet. And then on the right, we have to consider the possibility of machine-based life that runs on algorithms rather than biochemistry. So given our ignorance of the possible forms that life can take, we can't answer these burning questions about extraterrestrial life, through calculations. We don't know who or what is out there, so we need to observe and explore, and that's what I'll be discussing over the next half hour. So as you can guess, we're going to start off in our solar system. And Mars, of course, is the next planet out from the sun. And at times it comes pretty close to Earth. So it's relatively easy to reach with spacecraft. So and I think all of you know this history, but for very long stretches, many people just assumed that Mars was inhabited. Some thought there was abundant vegetation, but then you had people like Percival Lowell who thought there were intelligent beings on Mars. But NASA spacecraft visits to Mars in the 60s and 70s, starting with the Mariner missions and then later Viking 1 and 2, disabused humanity of those oceans. They showed Mars's surface to be cold, dry, barren, and with no obvious signs of life. But then you look at these two Viking orbiter pictures, and they reveal channels that look suspiciously like those that are carved by streams and rivers on Earth. So that's pretty tantalizing. So in 1976, two Viking landers touched down on Mars successfully. They were the first successful landings on Mars. On the left is a model of one of the Viking landers, and on the right is an actual scene from the Viking 1 lander, and that big rock in the distance is known as Big Joe. I've always really liked Big Joe. Both spacecraft carried mechanical arms and you can see a trench here that was dug by the arm that could scoop up soil samples and literally bring them inside the lander. So then each lander conducted 3 experiments to analyze this Martian material to see if it contains microbes that metabolize various organic nutrients and water and then release gas or other waste products. So I'm not going to go into detail about this because you'll have a speaker coming up on October 15th who will talk about this in much greater detail. That's Patricia Ann Stratt. But her experiment, which is called the labeled release experiment, actually obtained positive results for life on Mars. In other words, if you took the pre-mission criteria, this experiment found life. It found metabolizing microbes. The problem is that the other 2 experiments came up negative. There was also an experiment designed to look for organic matter, and that came up empty as well. So most scientists concluded no organics, no life. And they attributed these positive labeled release experiments results to some kind of active chemical ingredient in the Martian soil. But these results remain controversial to the present day. So I'll be talking tonight about trying to find life on other worlds. It's possible we've already discovered extraterrestrial life. And what's disappointing to me and the members of this labeled release team, both of the 2 main figures, Patricia Ann Stratt, Gilbert Levin, are still alive. Levin is 96 years old, but is still alive and active. What's disappointing to me and to them is that NASA has never sent a specific life detection experiment to Mars to follow up these tantalizing results. Having said that, though, Mars is cold and dry today, but as I mentioned, there's large bodies of evidence that have built up from both orbiters and ground exploration that Mars had liquid, water running on its surface billions of years ago. And where there's water, at least on Earth, there's life. So this gives you, a lot of optimism that Mars, sometime in its past, may have hosted life. Now, on the left is a Viking orbiter picture of Gusev crater, that big round crater at the top. But you'll see a long valley that's called, I don't know if I'm pronouncing it right, called Ma'adim Vallis that flows into it. And on the right, we see some imaginative artwork, but I don't think it takes a great leap of imagination to think that sometime long ago, water was flowing through that long channel like a river and then pooling in the crater to form a lake. So NASA sent the Spirit rover, which landed in January 2004. It landed inside the crater, took this spectacular panorama among many, many spectacular images it took from the surface. And here's a really nice picture of a layered rock formation in Gusev crater known as Gibson. And Spirit took its instruments up to these rocks, took all sorts of measurements. And, the scientists analyzing this data found that these rocks, contain clays and minerals that are very similar to those that on Earth that form in running water. So this theory that Gusev crater was a lake is almost certainly correct. That that there was liquid water here, a fairly substantial body of water long ago. There's also another tantalizing hint of possible life on Mars in the past. And I'm sure many of you remember this. This was a big international news story. In 1996, a team of NASA and Stanford scientists claimed that they had found chemical signatures of ancient life and possibly even fossilized nanobacteria, like we see that worm-like thing on the right, that was inside this rock. In other words, there was once microbial life inside this rock, dating back billions of years at a time when Mars was warmer and wetter. So these claims remain controversial because all of these signs of life that were identified by this NASA Stanford team can be explained by non-biological processes. So in my mind, there's good reason to be skeptical, but for me, it's still an open question. And then we have the fact that telescopic observations from Earth dating back more than 10 years, and now measurements on the surface of Mars from NASA's Curiosity rover have detected trace amounts of methane in Mars's thin atmosphere. And this diagram runs with my astronomy article. You can see that the methane goes up and down with the seasons. Now on Earth, 95% of atmospheric methane has a biological origin, like from the breakdown of certain biogenic materials, cows farting, methanogen bacteria. So this is kind of tantalizing. It's certainly not proof. There's a lot of other geological or chemical processes that can produce methane that don't have anything to do with life. But this is a tantalizing evidence that maybe there's still life on Mars right now. So on July 30th, just a few weeks ago, NASA launched its next Mars rover called Perseverance, or as the NASA people like to call it, they call it Percy for short. So I'll call it Percy. So Percy's going to land in a crater, I think I'm pronouncing it right, called Jezero, and it's going to land or crash on February 18th of next year, hopefully the former. And it'll touch down in an ancient river delta, which you can see in this, false color image. So it should find, an ancient river delta. So it should find plenty of rocks that formed in liquid water. And unfortunately, in my mind, Percy doesn't carry any instruments capable of detecting microscopic life, but it will collect rock and soil samples for later return to Earth. It's possible it could see mineralogical signatures from minerals that would only be formed in the presence of life. But really, the best bet is the samples it's going to collect. NASA and the European Space Agency are now planning a joint mission to return samples from Mars in the early 2030s. So NASA is going to provide the Fetch rover and the launch vehicle to collect the samples and launch them off Mars. And then Europe will provide the spacecraft that will rendezvous with this sample vehicle and then return these materials to Earth. I mean, I think it goes without saying this is going to be a very expensive and technologically challenging mission. But if it works, and it probably will, we'll have Martian material collected from a known location, and then scientists can study this material on the very best laboratories on Earth. So this analysis might resolve the life question, especially if scientists can find living or fossilized life forms in the samples. But it also raises a question. I don't know how you folks feel about it. Is it safe to return samples from Mars without knowing exactly what those samples contain? NASA officials have assured me that, these will be handled like in what they call class 4 labs, and there's no way these samples will get out into the Earth environment. The European Space Agency is also planning its own rover. Unfortunately, maybe the picture of Rosalind Franklin, for whom the rover is named, is covered up by the screenshots. She was a great British scientist. She did the X-ray imaging in the 1950s. Watson and Crick, they basically stole her data, and they used her data to discover the double helix structure of DNA. So I'm glad they named the rover after her. The rover was originally going to launch this year and arrive early next year, but then the ESA ran into problems when testing its parachutes, and then COVID-19 hit. So the launch has been postponed until late next year. It will land in an ancient Martian lake bed. It'll carry a suite of cameras, spectrometers, and a drill. It'll actually be able to dig down up to 2 meters below the surface and bring that material onto an onboard laboratory where it will be crushed into a powder and heated. And then there's 4 instruments will study that material for signs of organic compounds and biosignatures of past or current life. So I would say there's an outside chance that this European rover could discover life on Mars within the next few years. If these missions cannot resolve the life question, then perhaps future human explorers can dig down into underground aquifers and other places most likely to harbor life. It might really require sustained human exploration over many years to determine if Mars is a living or dead planet. But there's also a concern. Human colonists might contaminate Mars with terrestrial life to such an extent that it might diminish our chances of finding indigenous life. And of course, finding evidence of life on Mars would be an incredible discovery. For example, if Martian life, it turns out, is related to Earth life, it could not prove but imply that life originated on one planet and was transferred to the other inside a meteorite like ALH 84001, or maybe even and that, started somewhere else and was transported to both planets. But if Martian life is unrelated to Earth life, it would suggest then that life arose independently on 2 different worlds, which would imply that life will arise wherever conditions are favorable. And with all these hundreds of billions of worlds out there, maybe even trillions, I think that would almost guarantee that, our galaxy is just brimming with life. Now I'm going to move a little further out in the solar system to the icy moons, and we'll start with Europa. You can see it arrowed on the right, compared in size with Earth, our moon, and Jupiter's 3 other Galilean moons. Europa's bulk density suggests an icy crust overlying a thick layer of liquid water. And the Voyager flybys in 1979 revealed that the icy surface is crisscrossed with dark streaks. This is actually a Galileo image here. You can see the dark streaks. And that, is very suggestive that there's this water layer from below, that material is seeping upward through the cracks and onto the surface. Now, when Galileo took a closer look in the late 90s and early 2000s, it was a Jupiter orbiter, but it flew by Europa multiple times, sometimes at fairly close range, and it revealed these icy surface ice rafts that seem to be floating atop a watery layer. Galileo also discovered an induced magnetic field that indicates a subsurface salty ocean. And it even discovered organic material on the surface through spectroscopy. So this is an illustration, a model of Europa that ran in astronomy. So, scientists have actually even discovered from Hubble Space Telescope data and archival Galileo data of watery plumes shooting into space from Europa. So there is abundant evidence for a thick ocean of water on Europa. And this ocean probably contains more water than all the water in Earth's oceans combined. And this water layer is probably in contact with a rocky layer below. And Europa is heated by tidal energy resulted by being tugged upon Jupiter and its 3 other large moons. So Europa has all the ingredients for life as we know it. It has liquid water, organic molecules, and energy. So it's, for just an example of what might be there, it's not difficult to imagine hydrothermal vents on Earth analogous to those on our ocean seafloors. And, and these black smokers, as they're called, fuel rich, complex ecosystems in the complete absence of sunlight. So NASA is planning a mission in the early 2030s called Europa Clipper. It'll be a Jupiter orbiter, but it will fly by Europa 44 times over several years. It'll image almost the entire surface at high resolution and look for places where the ice appears to be relatively thin. And it should be able to fly through these plumes and give us some measurements about their composition. So Europa Clipper will hopefully pave the way, I hope, for a future lander, and that could search for signs of life on the surface. It's maybe seeped up through the cracks, but more important, we can kind of see here in this artwork, it could melt or drill its way through the ice and deploy some kind of submersible probe to explore the ocean and look for signs of life. This would be an incredibly exciting mission, but it's probably a long way off. I don't know if I'll live long enough to see it, but I visited my mother today in her nursing community, and she's 92 years old and she's still sound of mind. So maybe there's hope for me that I'll live long enough to see this. And, there could be at least a dozen other ice shell worlds in the outer solar system with substantial water oceans below the surface. One of the best targets includes Saturn's moon Enceladus that we see in this picture. But as of now, there are no planned missions to these worlds. And I'm really focusing this, talk on, worlds where there's missions. So this brings me to Saturn's large moon Titan, which is the second largest moon in our solar system. And this is an image from Cassini. And you can see this moon looks a lot different from every other satellite in the solar system because it's enshrouded in an atmosphere. And here we see Titan compared to Earth and our moon. What's really intriguing about this atmosphere is that it has similarities to Earth's atmosphere in both composition and thickness. Like Earth's atmosphere, the dominant constituent is nitrogen, although unlike Earth, methane is the second most abundant component in Titan's atmosphere. And also Titan's atmosphere actually exerts a surface pressure about 50% greater than the pressure exerted by Earth's atmosphere at sea level. So this is a pretty darn thick atmosphere. Now, Cassini carried a European-built lander named Huygens after the Dutch scientist Christian Huygens, and it parachuted through Titan's atmosphere and landed on January 14th, 2005. As it was parachuting to the surface, its descent camera, which was actually built at the University of Arizona, took this amazing picture of what appear to be river networks on the surface. And that's probably what they are, except on Titan, the rivers flow with methane, not water. And then we got this amazing image that Huygens took from the surface. The rocks that we see here are actually made of water ice, and they appear smooth, possibly because they've been eroded in flowing liquid methane. The problem, however, with Titan is that the surface temperature is minus 290 degrees Fahrenheit, which is probably too cold for life as we know it, because chemical reactions slow to a crawl in such frigid conditions. But there appear to be hydrothermal areas, both on the surface and underground, where temperatures could be much warmer and more conducive to life. And Titan might also have a subsurface ocean containing water and ammonia, and who knows what's there. And very intriguingly, Cassini also carried a radar instrument which returned stunning data of lakes on Titan's surface. And you can see a bunch of lakes here very near Titan's North Pole. Now, the largest of these lakes are comparable in size to the Great Lakes. And you guys all know all about the Great Lakes living outside Detroit. So despite the cold temperature, Titan's still of great interest to scientists as a potential abode of life, or perhaps even prebiotic chemistry. And amazingly, Titan has a methane cycle very similar to the water cycle on Earth, where methane rains out of the atmosphere. We see this in this really wonderful piece of space art by Mark Garlick. It then forms rivers and lakes, as we've seen, and then it evaporates to form clouds, which then produce rain, just like water on Earth. So if there is life on Titan, however, it would probably use methane or ethane as a solvent rather than water. So it would be life 2.0, life as we don't know it, probably. So NASA has approved what I think is an incredibly exciting mission called Dragonfly to study Titan up close. They call it a rotor craft. It's basically a small robotic helicopter that will be able to explore multiple locations with a suite of instruments. It will study surface composition, atmospheric conditions, and geological processes. It's scheduled to launch in April 2026 and arrive at Titan in December 2034. You know, this is a very challenging mission technologically, but if it works, and it probably will, it could conceivably find evidence for non-water-based life, or at the very least help scientists better understand the origins of life. Take a quick break for water. So now it's time to leave our solar system behind and turn our attention to planets orbiting other stars. And I think all of you know this, they're known as exoplanets. So I checked the European Exoplanet Encyclopedia just a few hours ago, and astronomers have found 4,326 exoplanets. And this is amazing. That's 540 times as many planets as we have found orbiting the sun. And as I've mentioned, our galaxy has hundreds of billions of planets, perhaps as many as 1 trillion, but they're very far away. Even the closest known planet is 25 trillion miles away. So we're not going to be studying them up close anytime soon. How can we study them for signs of life? Well, the diagram here on the left shows how it can be done. And astronomers are currently using this method using Hubble and various other telescopes to probe exoplanet atmospheres. And they're basically observing planets that periodically cross in front of their star from our line of sight. And we call that event a transit. I think all of you know that. So as the planet transits its star, some of the star's light will pass through the planet's upper atmosphere, where elements and molecules will absorb light at specific wavelengths. So we see on the right kind of a sample spectrum where you take a spectrum of the star when the planet is in transit and when it's out of transit, and the spectral lines that show up only when the planet is in transit are like fingerprints that reveal elements and molecules in the planet's upper atmosphere. So here we see, samples of what alien astronomers might get, spectra of Venus, Earth, and Mars. So, when scientists study on other planets would study these spectra, they would be pretty interested. They'd be mostly interested in Earth because they would see that line for O3. That's, oxygen molecule with three oxygen atoms, or ozone. That would be a very strong potential biosignature. Most of the oxygen in Earth's atmosphere is due to photosynthesis and other biological processes. So, astronomers from afar are observing Earth, they would say, oh, wow, this is a pretty interesting world. And the fact that they see it in combination with water vapor and carbon dioxide, that makes Earth a very promising abode for life. They would look at Venus and Mars, however, and just see carbon dioxide, which can be easily produced by non-biological processes. And they would conclude, well, these two planets aren't as promising as that third planet from the star. And there's another possibility as well. If astronomers see certain combinations of molecules and atoms in an exoplanet atmosphere that should not exist together, like they would break down, that's called disequilibrium chemistry. That would be a very strong, compelling biosignature, although perhaps not absolute proof that a planet hosts life. So astronomers have been using this technique now for a number of years. They've discovered many dozens of chemicals in exoplanet atmospheres, including molecules such as water vapor and carbon dioxide. But the current telescopes have their limitations, often with, the sizes of their mirrors. But late next year, NASA is going to launch its James Webb Space Telescope, or JWST for short, finally, after many years of development. So JWST will have a 6.5-meter mirror, more than twice that of Hubble, and it'll be optimized for infrared observations, which could reveal, water, ozone, methane, and CO2. So JWST will be able to observe stars within a few dozen light years of Earth that have transiting planets. They're going to concentrate on stars that have planets known to orbit in the habitable zones, where temperatures and conditions should be, good for liquid water on the surface. And one very compelling target will be TRAPPIST-1, which is a small, cool red dwarf 40 light years from Earth. Now, if you look at this diagram, those 7 planets, look, you can see there's a line there that says enlarged 25 times. These planets are all crammed in very close to the host star. So it's a very dim, low luminosity star, but 3 of them are close enough to the star that they're in the habitable zone. So, this is a very, very promising target to do these kind of studies. But even better, our 3 different international consortiums are building giant land-based telescopes with mirrors ranging in size from 25 to 50 to 40 meters. So you can see them here clockwise from the upper left. We have the 30-meter telescope in Hawaii, the giant Magellan telescope in Chile, and the European Extremely Large Telescope also in Chile. And these telescopes will be equipped with state-of-the-art instruments with extremely high spectral resolution. Because they're on Earth's surface, they're going to be primarily optimized for visible light observations, although they can get a little bit into the near infrared as well. So they could detect molecules such as oxygen 2, oxygen 3, and water vapor. So if life is very common in the galaxy, where a lot of these habitable zone planets have life, I think there's a decent chance that one or more of these telescopes will indeed detect biosignatures on one or more exoplanets. Even more exciting is astronomers are developing next generation telescopes and instruments. This is one called ExoLife Finder, or ELF. Right now, astronomers are developing a prototype, and it has this advanced technique. I'm not even sure I fully understand it myself, but it uses kind of a combination of interferometry and a coronagraph to block out the light of a host star. So, one of the problems with studying exoplanets, they're, tiny, tiny angle from the star, and the star outshines the planet by like 1,000,000 to 1, or, depending on the wavelength. So the astronomers need to really cut the glare of the star and reduce it to almost nothing to really get great data on the planet. But if this ELF is built and works according to specs, it'll probe deep into exoplanet atmospheres and perhaps even take images of planetary clouds and surfaces. It could possibly image oceans and continents on other planets. And this would even include planets that don't transit their host star. And of course, the vast majority of known planets don't transit. So one of its targets will be undoubtedly Proxima Centauri b, which is the innermost of 2 known planets orbiting Proxima Centauri, which is the nearest star to the sun at a distance of 4.2 light years. Once again, that's still 25 trillion miles. So we know virtually it's not a transiting planet. So we don't know much about it other than the fact that it's slightly more massive than Earth and orbits at about 1/20th the distance that the Earth orbits the sun, or about 0.05 AU. Now, Proxima is a feeble red dwarf, but this planet, because it's so close to the star, lies within its habitable zone. So to really get the best possible data, astronomers would love to put a large telescope in space that is optimized for exoplanet studies. So NASA is currently, has this large telescope on the drawing board called LUVOIR, for Large Ultraviolet Optical Infrared Surveyor. And if it gets built and launched and works according to specs, it will provide detailed information about hundreds of exoplanets, and it would probably resolve the question of how common life is in the galaxy. But this thing is very far in the future, and politics, more than science, will dictate if and when it will get built. And so now I get to the fun or crazy final part of my talk, which is the search for extraterrestrial intelligence. I'm sure all of you know the acronym SETI, but I'm going to try to expand this discussion to go a little bit beyond traditional SETI programs that look for radio signals. And with these telescopes, astronomers are going to be looking for technosignatures. Those are signs of advanced civilizations that are modifying their planets or environments in ways that we might be able to detect. And I think that thinking about, possible technosignatures is fascinating, but of course it's highly speculative. It's because it forces us to consider the kinds of activities that civilizations millions of years in advance of ours might be doing. Think back just like 200 years ago. I mean, you had smart people like Ben Franklin and Thomas Jefferson. None of them could, had any idea what we'd be doing 200 years later. So we don't really have any idea what a civilization millions of years of advance of ours might be doing. So I love this piece of art. Who knows? We can't do it, but maybe some hyper advanced civilization would build a space colony orbiting a black hole that taps into this, rotational energy or the energy of material falling into a black hole. Who says a civilization far in advance couldn't do this? This is my only trivia question tonight. And I'm not going to give you much time to give an answer, but, my question is, what do these different things, these 8 things in this slide, have in common? And the answer is that all of them are important astronomical objects or phenomena that were discovered through serendipity. This means that astronomers discovered them without specifically looking for them. Basically, what happened is technology had crossed a threshold that made the discovery possible. And once we had the technology, we started finding these things. So my point is, we don't know what highly advanced civilizations are doing, so we don't know, how they might appear in our telescopes. So if we discover one or more civilizations, it's quite possible the discovery will be serendipitous. And of course, a major unknown factor is how many civilizations are out there in our galaxy. And that will determine how difficult or easy it will be to find these civilizations. So in my opinion, this is not a question that we can calculate or estimate, although believe me, astronomers and scientists have tried. I think this is a question we can only answer through observations. Now, of course, since the early 60s, astronomers have been using radio telescopes or arrays of radio telescopes, such as the Allen Telescope Array, which we see here, to search for radio signals from advanced civilizations. And I need to emphasize, I think a lot of people in the public think that SETI is what radio astronomers do. Well, in reality, SETI is only a tiny, tiny part of what radio astronomers do. And in fact, in recent years, SETI projects have often piggybacked on regular radio astronomy observations of stars and galaxies. So, so far, SETI has not picked up any clear-cut alien signals, but SETI's just basically scratched the surface. So these searches are ongoing and are becoming increasingly sophisticated thanks to advanced receivers that can sift through millions of narrowband wavelengths simultaneously. The most advanced radio SETI project right now is called Breakthrough Listen. It's funded by the billionaire Yuri Milner. It's using radio telescopes like this 100-meter dish in West Virginia to search for extraterrestrial signals. So if there are large numbers of radio transmitting civilizations out there, maybe someday a SETI program will hit the jackpot. But I agree with Dale, who he sent me a YouTube link for a lecture he gave to your club recently. I actually pretty strongly agree with him. I'm not holding my breath that radio SETI is going to detect ET. Another recent strategy that's been employed is what's known as optical SETI, where several groups are searching for powerful laser signals transmitted by other civilizations. The most advanced group seems to be a group based out of University of California, San Diego. They've recently installed a near-infrared detector on the 1-meter telescope at Lick Observatory to look for laser signals. They're also working on an even more advanced instrument to install on one of those next-generation telescopes I talked about a few minutes ago. So I think these optical searches are well motivated, and I think it's important not to put all of our SETI eggs in one basket. But once again, I'm not holding my breath. Now, I talked about ExoLife Finder a few minutes ago. One of the things that it could potentially find, I mentioned it could find all sorts of chemicals in the atmospheres of exoplanets. Well, it could also find artificially produced chemicals such as chlorofluorocarbons that, these would be gases that aren't going to be produced by any natural process. So we find something like that and it's the spectrum of an alien, an exoplanet, and bingo, you can be pretty confident there's life there. And one of the team members, Jeff Kuhn of the University of Hawaii, told me that ELF could even potentially detect the thermal emission of cities on the night sides of nearby exoplanets. So this is just a wonderful piece of art detecting what such a planet might look like. What an incredible discovery that might be. another quick water break. So in 1960, the physicist Freeman Dyson popularized the idea that highly advanced civilizations could build a swarm of space colonies around its host star to harvest some or even most of its radiant energy. So this artwork depicts what one of these Dyson spheres might look like. Such a megastructure would take the heat from the light from the star, and then that light would be re-radiated, kind of its waste heat would be re-radiated in the infrared. So astronomers have actually looked for stars and even entire galaxies that are much brighter in the infrared than they otherwise should be. So it's possible, that such a technosignature would give away the presence of extraterrestrial life. And this is just one of many proposed technosignatures that astronomers could potentially detect with current or near future telescopes. Now, there's a Penn State astronomer named Jason Wright, who I love interviewing, and he just recently recorded a podcast on the Event Horizon website. And he pointed out that we can't even rule out the possibility that advanced civilizations have visited our solar system. And as a case in point, and I actually watched a show about a year ago about this on the Discovery Channel, that airplane radar has recently revealed ancient Mayan cities whose remains lie just inches below the surface, and yet we were completely unaware of their existence until just a few years ago. So Wright makes a persuasive argument, that we've barely even begun to explore our own solar system. And think about, Arthur C. Clarke's, he portrayed this idea in the book and movie 2001: A Space, where future human colonists on the moon find this artificial monolith just below the surface. So if we start exploring other moons and planets up close, who knows what we might find? And I don't think this idea is crazy at all. Jason Wright said to me, we could be completely unaware of active or derelict alien probes that are orbiting the sun right now. And it would only take a thorough exploration of the vast expanses of interplanetary space to find these things or to rule out their existence. So if you accept the possibility that other civilizations might exist, or that some of them might endure for millions of years, it's quite possible that some of them will develop interstellar travel, and Earth would be a compelling target for exploration. So, and I would even argue, I don't, see any kind of, proof that this is happening, but I wouldn't even rule out the possibility that Earth is being observed right now by a more advanced civilization. And it's not even impossible that Earth could have hosted an advanced civilization, maybe even an indigenous civilization, many millions of years ago. This is an idea known as the Silurian hypothesis. There was a paper published recently in the journal Astrobiology, which is, a very reputable refereed journal, that if you had a civilization on Earth millions and millions of years ago, that erosion and plate tectonics would have erased almost all signs that ever existed. So we can't even rule out the possibility that maybe humans are like civilization 2.0 or 3.0 on Earth. So I just want to conclude that, if we ever do find another civilization, it might answer the question whether humans might have a post-biological future where we merge with machines or produce artificial intelligence that takes our place. So if we find another civilization, maybe it'll be machine life. And if that civilization is far more advanced than ours, which is highly probable, it would give it, the good news is it would give us reason for optimism that relatively primitive technological civilizations like ours can survive their technological adolescence. and confirming the existence of another civilization might have profound ramifications for our society in ways that we cannot predict right now, especially if we can, obtain some detailed information about that civilization. And even if we don't find civilizations, but we just find, primitive extraterrestrial life, that would still be fascinating. It would give us insights into our origins. We'd learn more about, what kinds of planets and environments can support life, and what kinds of, possibly what kinds of, really different alternative life forms might be possible. And even a negative result is interesting. Let's say we go decades and decades with better and better telescopes, more exploration of the solar system, and we just don't find any extraterrestrial life. That negative result would be interesting, because it would imply that life maybe is not, it wouldn't tell us that there's no life out there, but it would tell us that life is maybe fairly rare, that it happened on Earth, but maybe it doesn't happen very frequently. And that might give us more incentive to protect the life that we have right here on Earth. So I think no matter what we find or don't find in the coming years and decades, the search for life on other worlds will tell us a lot about ourselves and our place in this wondrous universe. So thank you very much, and I will be very happy to take your questions. And
Fabulous. Thank you. Thank you.
Yeah, I enjoyed it. I'm going to quickly jump in because I know there will be a few questions.
Okay.
Has there ever been any thought given that the aliens could be us from the future after we learn time travel and then come back to Earth at this time? Is that a possibility?
That's actually a really interesting question. I haven't thought that much about it, but I remembered reading it. This was, probably 5 or 10 years ago. I read an article where there are, science historians who actually go back and read books and diaries to see if they can find any evidence of people from the future visiting the past. So I do know that people have thought about that possibility, and including the possibility that there could be humans on Earth right now that come from the future and have time traveled into the past. The problem, of course, is that you get all sorts of, causality, problems, things like what happens if you go back and kill your grandmother before your grandmother gave birth to your mother, then you're never, you never been born. But then if you're never born, you can't go back in time to visit yourself in the past to kill your grandmother. So I don't know. I know, as I said, I haven't really thought about that, but I know that smart, serious people have thought about it. And that's a possibility that I would argue we should not dismiss.
All right, sounds good. I have a friend who believes that the alien civilizations are there, and I informed her about the talk. You've made her very, very happy.
Okay, good.
She feels like she's right. So
okay.
I'll leave it there.
And as I said, I'm agnostic. I'm really agnostic. I did a cover story in 1996 when I worked at astronomy titled, "Okay, Where Are They?" arguing that Earth might be the only planet in the galaxy with with a technological civilization. And then when I was editor of Sky and Telescope a few years ago, I wrote an editorial, kind of saying, well, there probably aren't that many out there. I guess I've sort of changed my mind in the sense I'm more agnostic now. I think, as I said earlier, we just don't know. I think, I can believe the people that think n equals 1 in the Drake equation, but I can also, the people who think that n is, a much larger number. I think they might be right too. I don't believe n is in the millions. I think if it was in the millions, we would have clear and obvious evidence right now. But I don't think that the fact we don't have, proof of aliens, civilizations, doesn't mean that n couldn't still be a number significantly larger than 1. That's just my opinion, though. As I said, I don't think anybody really knows what's out there or who's out there.
All right, I'm sure we have more questions.
I would comment that with regard to Adrian's question, many science fiction stories were written back in the 1950s and 60s and 70s exploring what if we were a visit. I mean, just every scenario anybody could think of has had science fiction writers thinking of them ahead. And I'm not saying because it was science fiction, it's wrong. I like reading science fiction, right? I'm just saying there's a wealth of thought out there exploring these kind of scenarios.
Yeah, I agree. Yeah, and a lot of very thoughtful and very imaginative science fiction. In science fiction, I mean, for example, I mentioned the idea of like plasma life. Well, the great British physicist Fred Hoyle came up with a book. I think it was called The Cloud, or what was it? But he came up with this very and he wrote a science fiction novel about the idea of an interstellar cloud being alive and having consciousness. So, I think given our profound ignorance, the science fiction writers are doing a lot of favors and giving scientists ideas of what might be out there. So I agree totally with what you're saying.
Communication with us, a life form that is completely different than us and doesn't have the same value structures and all the other things that we go with it. And none of them may not even be interested in travel or love or government or anything like that. And I always kind of wondered that since there's such a variety of planetary situations, different gravities, different mixtures, all those things, it would seem to me that it would be very, very difficult to ever even communicate, no matter how advanced they are. I would always wonder that.
And that's a great point, and you could be totally correct. I mean, kind of the radio and optical SETI is predicated on the idea that these civilizations, they're interested in science. They discover radio waves. They're interested in mathematics, that there's some parallel, convergent evolution, even though we're on different worlds, that these civilizations are going to have at least some commonalities with us. So, that would make communication possible. But I think, once again, we're just showing how little we know. There could absolutely be intelligent life out there that, we would even have a difficult time even recognizing as intelligent life. For example, I think of the one of my favorite science fiction writers is the Polish science fiction writer Stanislaw Lem, and he wrote a novel called Solaris, which the Russians later made into a movie, and then George Clooney made into a movie where he was the star of the movie. And the premise of this novel is that there's a planet called Solaris that's covered in a global ocean at the surface, and the ocean is not only alive but has a consciousness, but it's a consciousness so different from ours that we have like an incredibly difficult time communicating with it or even recognizing that it's conscious and intelligent. So I totally get your point. And this is another area I think where the science fiction writers are, paving the way by exploring what's possible, what might be possible out there.
I would comment that while all kind of scenarios are conceivable, that other civilizations could think very differently than we do. Yeah. I would argue that if only a third of them, for example, or pick your fraction, think kind of like we do, then that's enough to find them if they're out there. And physics is physics. The electromagnetic spectrum is what it is for anybody. And I would also argue that intelligence at least often implies a certain aggressiveness for survival and ultimately leads to some kind of technology. Otherwise, what's the intelligence for? You know, I mean, so I'm not saying all civilizations would be like us, but some would.
Yep. Yep. I agree. And I would even point out that, I mean, you know, I showed the picture of my cat earlier. You know, me and my dad were allergic, so he was an outdoor cat. And, you know, I learned what happened is my sister had moved and she had this cat and left it with me and my parents. And I had never owned like a cat or a dog before. I was in high school, but because my dad and I were allergic, we just kept it outdoors. I learned very quickly that our cat was very intelligent and was quite capable of fending for himself. But I also could tell he was violent, that, you know, he killed, and eventually, you know, my mother and I decided to put a bell on him to give the little chipmunks and squirrels a chance. I'm sure our cat didn't appreciate that. But, you know, I could tell, you know, and you see that on Earth, that as species get more and more intelligent, you know, they tend to be the predators, and they definitely have the capacity for violence, you know, programmed into their genes. And it's definitely quite possible. I mean, people have written science fiction books, you know, about how, you know, you have some advanced civilization that builds like what are called, like Fred Saberhagen wrote about berserkers that would go around destroying any planets as soon as they started showing signs of intelligent life. You know, that if you were the first, you know, civilization to emerge in the galaxy, and you survive this technological adolescence, you might have a compelling reason to prevent any other civilizations from emerging. If that's the case, you know, we're probably being watched right now, and you know, they're probably leaving us alone for now because we haven't gotten to the point yet where we're dangerous. But if we get to the point where we really start getting dangerous, you know, with interstellar travel, they might at that point just wipe us out. I'm not saying that's going to happen. I doubt it, but I don't think we can rule that out.
We would need a space force.
Yeah, that's right. Yep.
Don't forget the Krell.
Do I get to talk now?
So, poor
Excuse
Gary
me.
Russ. Go ahead.
Excuse me. I have something to say.
Yes, sir.
Bring back Federer, Ashbrook, and that tar-heeled snob Shawcross. Whenever I hear all this guff about science fiction at a Warren Society meeting, like Hermann Goering, I reach for my revolver.
Well, thankfully we're all virtual now, so there's the screen out like Elvis Presley.
I think that was Mission of Burma, Gary. I actually, so there's a question from YouTube here, and it will further dismay our science fiction, our friend Gary, who prefers to keep his science fiction away from his astronomy club meetings. But that is, a video game franchise has a sentient alien race which uses ammonia as a solvent rather than water and thrives at temperatures where it is a liquid. Is this possible?
I'm just having really trouble hearing you clearly.
Sorry.
Oh, there we go. Now it's better. Now
Is this any better? Okay.
Yeah, that's much better.
So the question from YouTube said, a video game franchise has a sentient alien race which uses ammonia as a solvent rather than water and thrives at temperatures where ammonia is a liquid. Is this possible? I thought ammonia was a liquid.
You know, I'm not an expert on biochemistry, but I have I think I've recalled reading that as a possibility. So I don't want to really give a definitive answer, but I would not rule that, based on what I know, I would not rule that out. And you might remember I mentioned Titan earlier, that Titan might have a subsurface ocean with water mixed with ammonia. And of course, ammonia would lower the freezing point of water. So you could imagine, some kind of life in in an ocean, with water and ammonia mixed together.
Not an expert in it either, so sounds plausible to me.
And by the way, I just want to mention, I fully get the point, about, don't get too much science fiction in science. But I mean, I can tell you, I interviewed a lot of different scientists for this article, and, these are high level scientists who are getting papers published in, leading scientific journals. And, they think about this. And, especially back in like the old days of Sky and Telescope, the telescopes back then wouldn't be able to reveal the kind of stuff that I was talking about, these technosignatures that I was discussing in the latter part of my talk. But the telescopes we're going to have at our disposal in the very near future, that are being built right now, might be able to see this stuff. And, I know from talking, for example, Andrew Simeon, the leader of Breakthrough Listen, I mean, he says, we go to our science conferences and we tell our colleagues, have your mind on the lookout for something unusual that we can't explain through a natural process. So I can tell you that, leading scientists are thinking about this stuff. And it's because, the technology we have now is at the point where this stuff suddenly, as I said, with the serendipitous discoveries, these technosignatures, right now we can't detect them because our technology isn't quite good enough. But once technology crosses a threshold, suddenly all sorts of these objects pop out. I mean, think of Kuiper Belt objects. Clyde Tombaugh found one in 1930, but then starting in the 90s with, computers and CCDs and computers that could do analyze the images, suddenly we went from one Kuiper Belt object for decades and decades and decades. I think now the count is I think it's in the hundreds of thousands now. And exoplanets, for centuries, we're wondering, are there planets out there? Well, as I said earlier, we now know of over 4,300 planets orbiting other stars. So it could be that with civilizations, we cross a technological threshold and suddenly they start coming into view. So I think it's actually quite scientific and reasonable to think about this, of what might be out there, and give it some thought.
Very cool. Are there any other questions? I don't think there are any more on YouTube.
Yeah, I just want to say those were some really great questions and very, very thoughtful, thoughtful. I mean, as I said, I think this whole field should encourage us to think very broadly, especially when we're talking about intelligent life, but even like, plant and animal life. I mean, who knows what's out there? So I think, we need to think broadly, and realize that as the technology gets better, we might start seeing stuff that that hardly anybody or nobody's imagined.
All right. Well, thank you so much for
thank you.
joining us tonight.
Thank you all for tuning in. I hope this was more interesting than politics.
Well, there's always you can always watch the replay on YouTube from
That's right.
the thing.
That's right. Yeah. Okay, great. Well, thank you for all tuning
Thank
in.
you.
Thank you very much.
Have a
Anything
great
is
night,
more
everybody.
interesting than politics.
Fantastic.
We'll see you all at the virtual picnic on Saturday.
Yep. Take care, everyone.
All right.
See you
Thank you.
there.
Looking forward to it.
All
Good
right.
night.
Bring your recipes.
Consider it a dry run for astronomy at the beach on the
Yeah.
web.
Yeah.
Yeah, I'll be paying close attention to that.
All right. It's going to be the first ever BYOB Warren Club picnic.
Do we have a
All of them
YouTube
should
count?
be BYOB. Wait, all of them should be BYOB, right?
Yeah,
Whether
but we
it
can't
works
at the
or
park. The metro parks don't allow it, but
Sorry, Glenn. Glenn, we got to. I think we got to about 57 people all told. I think we had about 23 on YouTube, and we had several people join and then have to go from the WebEx. So we had really great turnout tonight.
Thanks, John.
Love it.
All right.
Thanks, Bob.
Thanks,
all
everyone.
right.
Thanks, everyone.
Thanks again.
Good night, all. Thanks
Night.
again, Bob, for joining us.
Yes.
Yep, my pleasure.